So in this lesson, we'll be covering quadratic sequence. I've prepared 3 questions that will address all the misconceptions and areas that learners struggle with. And with these 3 questions, really just like a schematic mock-up of what the exam questions would look like. So if you go through these questions, you should be well prepared for the exam and you should understand the fundamentals of quadratic patterns. So what we need to know, the background information of quadratic sequences, it's that the general term is given by Tn is equals to a n squared plus bn plus c, and you have to know 3 formulas. First formula is that 2a is equals to the second difference, and that 3a plus b is equals to the first difference, or the first term of the first difference, and a plus b plus c is equals to really the first term. Really, this is really more the background of it, and I'll show you how to find your first difference, your second difference, really, and how to work around that. So with this really small background, let's attempt the first question. We asked to write down the next 2 terms of the pattern. So our pattern is -4, -10, -18, -28. And how do we get our differences? We have to construct something called the tree line of differences, where substitute, just subtracting the second term and the first term, the third term and the second term, and the fourth term and the third term. So this will be -10 minus -4, and if you say -10 minus -4, it's nothing more than -10 plus 4, which is -6. Do the same thing for the next term, which is -18 minus -10, which is nothing more than -18 plus 10, which will give you -8. And we do the same thing for -28 minus -18, -28 plus 18. It's nothing more than -10. So we can see that the first difference is -6, -8, and -10. This is the first row, first differences. So we need to continue the process and say -8 minus -6, which will give us the second difference. So it will be -8 minus -6, which is nothing more than -8 plus 6, which is -2. And we do the same for -10 minus -8, which is -10 plus 8, which is nothing more than -2. So we can see that really the second difference is common, which really confirms that this is a quadratic. But really the values that really we'll be interested in more, it's the first term of the first differences, and really the common difference. So let's go back to the question. It's saying we must find the next 2 terms, really. So to find the next 2 terms, we just need to continue this pattern and see what we will find. Suppose that this pattern continues. What will we get? So we can see that it's 6, -8, and -10. So the following number here will automatically be -2, because we're adding -2 to that. -8 minus 2 is -10, and -2 minus 2, and -10 minus 2 is -12, and you continue. -12 minus 2, it's -14. So we do the same thing for these values at the top. So if you say -8 minus 10, you get -28. And if you say -28 minus 12, you should get the next term, which will be -40. And if you say -40 minus -14, you get -54. So really the next 2 terms of the sequence are -40 and -54. Then we would have answered our question just by understanding how really the sequence and number pattern works. And we can move on to the next question, because we would have answered number 1. We go to answer number 2. So if we can go ahead and really then just clear and make some space here, and then we're gonna go to the second question. So the second question is asking us to determine the nth term, or Tn, and they're giving you that nth term, Tn is equals to a squared plus Bn plus c. How do we calculate that? The first formula we're going to be using is 2a is equals to really the common difference, or the second difference, and the second difference here is, we can say 2a is equals to that, and we can say 3a plus b is equals to that. Then we can say a plus b plus c is equals to -4. That's how really you have to visualize it. So it will be equals to -2. Therefore, a is equals to, divide both sides by 2, -1. Then we're done with that first part of the formula. We go to the second part, which will be 3a plus b is equals to -6. Go to -6, and we know that a, as we calculated, is -1. And 6, so it will be b is equals to -6. Take the 3 to the other side, it will be +3. Therefore, b will be equals to -3. And to calculate c, really we're done with that. We go to using that formula there, a, b, c, so it goes to -4. It will be a plus b plus c is equals to -4. We know what our a is, and we know what our b is. Our a is -1, and we know our b is -3, plus c is equals to -4. We isolate and solve for c. It will be -4 plus c is equals to -4, and c will be equals to -4 plus 4, and therefore c will be equals to 0. So really we have to write this really in the form of general term. And how do we do that? We have to stipulate what Tn is equals to. Therefore, our Tn is written as, our a value is -1, so it will be -n squared, and our b value is -3, it will be -3n, and our c value is 0. So therefore, our general term, Tn, is -n squared minus 3n. And you really don't have to take my word for it. You can always prove if this formula is correct by really substituting any value for n. For example, if you substitute 3 where there's n, if you substitute 3 where there's n there and there, you should get the value of -18. And this is one way of making sure that you never really miss marks in this section, because you can always prove your work or prove your answer. In that sense, you know that you're banking all the marks. So let's move on to the next part of the question, which is question number 3. We've done question number 2. And question number 3 is asking us which term of the sequence is equals to -810. So if they're asking you which term, they're asking you for n. And they're giving you the value, which means that this is Tn. So remember, we have our general term here of Tn is equals to -n squared minus 3n. So the Tn will be -810, and we will be calculating the n value for that. And really, we're going to take everything to the left hand side. So this looks more like a quadratic equation. -810 is equals to really 0. So really we need to find really what the factors are that which you add, factors of 810, that which you add, that will give you 3, and that which really you multiply will give you -810. Really you can use trial and error to determine which terms are those. And if you're unsure of what method to use, you can always really use the quadratic equation. And in this instance, we can just quickly use the quadratic equation and see what value we get. So our a value will be 1, our b value will be equals to 3, our c value will be equals to -810. So really x will be equals to -b, which is 3, plus minus the square root of b squared, which is 3 squared, minus 4a, which is 1, and c -810, all divided by 2a, which is 1, And if you're really more efficient with this method, it will save you a lot of time, and it will guarantee that you get all your answers correctly, because you are more efficient and really you're banking all the marks that you can get. So if you quickly substitute this into your formula, you should get the first value of x, and then we're going to move on to the next value of x. And the first value of x will be equals to 27 if you're using the plus sign, or the next value will be equals to -30 will be the next answer, -30. And we know that really we're not solving for x, we're solving for n. So wherever there's x, we just need to substitute n, because you're not solving for x, we're solving for n. So you can go and substitute n, 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 and we know that n can never be negative. So we know that n cannot be equals to 30, and n is equals to 27. So that will be the value of n that we have calculated. If you want to prove if n is correct, you can take the n and substitute it back into the original equation, and you should get the same value as 810, really. And this is what I love about sequences, that you always check your answer one way or the other. So let's move on to another question, and that's more a mere intermediate question. So in this question, really, let me just label this question B. In this question, we're given the sequence, which is a quadratic sequence, and note that we have a delinquent of y. That's spicy. We asked to calculate what y is, and hence otherwise determine the nth term of the sequence. So when you see such a question, don't fret, don't be dismayed, don't panic. Just really go back to your principles of what a quadratic sequence is, and really the fundamentals of what properties the quadratic sequence it has. So we have to calculate the value of y. So whenever really you have a sequence like this, what you need to do is to go back and construct your tree line of differences. And your tree line of differences will tell you a story. So you're going to say minus 6, minus 3, which is nothing more than 6 plus 3, which will give you -3. And you're going to say y minus 6, y minus 6, which is nothing more than y plus 6. And I'm going to go ahead and say -18 minus y, really, which is nothing more than -18 minus y. So this is our first differences, -3 y plus 6, -18 minus y. And since it's a quadratic, we know that it has 2 rows. To calculate really the second difference. Second difference, say y plus 6 minus 3, which is nothing more than y. 6 minus 3 is nothing more than 6 plus 3, which is plus 9. And we'll say -18 minus y plus 6. And this is -18 minus y. Take out the negative, which will be -y minus 6. And we can continue really and simplify this to something more simpler, so as it's not as intimidating. So as you give us -2y, then we can say -18 minus 6, give us -24, and that will be our second difference, the row of second differences. So we know that these two values should be equal. Remember the properties of a quadratic sequence. The second difference are constant. So therefore, we can really expand on that knowledge and use that to our advantage. So what we're going to do, we're going to equate the two values. We're going to say y plus 9 is equal to -2y minus 24. And really, we're going to solve for y. Take the -2y to the left hand side, will be plus 2. Then we get -24 minus 9. And we have really 3y. And then we're going to say -24 minus 9, -33. and we're going to divide both sides by 3. We're going to say 3 divided by 3, it will give us 3. Negative 33 divided by 3, it will give us negative 11. So we found what the value of y is nothing more than. So we would have answered the first question. And now we go into the second question. They say hence or otherwise. Really, when they say hence or otherwise, it's nothing more than a fancy way of saying just use the previous answer to answer this question. And we need to find the nth term of the sequence. And the nth term of the sequence is Tn is equals to an squared plus bn plus c. So let's go ahead and find our Tn. Which should be more or less simpler. I shouldn't erase that because we need that. So what we're going to do is just substitute the value of y. Substitute the value of y, and then in that case, we'll be able to find what our general term is, sequence. So we're on question number 2, and we calculated that our value of y is negative 11. So we go back and construct our tree line of differences. So to be negative 6 minus 3, which would be negative 3, negative 11 plus 6 or minus 6, which will give you negative 6, and negative 18 plus 11 or negative 18 minus 11, which will give you negative 7. And then continue with the tree line of differences. And you're going to say negative 3 minus 3, which is nothing more than negative 6 plus 3, which will give you 3. And you're going to go ahead and say, let's double check something. No, it's not negative 6, it's negative 5. Beg your pardon. That's negative 5. And negative 5 minus 3, nothing more than minus 2. Negative 7 minus 5 is nothing more than minus 2. So you can see that your second difference is common, or it's constant. So we need to find our general term. And how do you calculate this general term? We know that 2a is equals to the second difference. We know that 3a plus b is equals to the first term of the first difference. And we know that a plus b plus c equals to the first term. So we go ahead, find our a value, which would be dividing both sides by 2, which will give you negative 1. Then if down at the first part, we go to the second part. 3 plus b is equals to negative 3. We know that what a is negative 1 plus b equals to negative 3. Then we know that it will be negative 3 plus b equals to negative 3. When we take the 3 to the other side, it will be negative 3 plus 3, which will be b is equals to 0. Then we move on to a, b, and c, which is equals to negative 3, which is our first term. We know that a we calculated is negative 1, and we know that b we calculated is 0. C equals to negative 3, and we take the negative 1 to the other side of the equation. It will give us plus 1, and c is equals to negative 2, and therefore our general term Tn is nothing more than negative n squared, and our b value is 0, so we can just say 0n, and our c value is negative 2. Therefore our general term is negative n squared. This will give us 0 minus 2. And before we move on, just take the time to really confirm if this answer is correct by substituting, for example, T4. Let's say you substitute T4, where there's n, wherever there's n, substitute 4, and see what answer you get. If you don't get the same answer as negative 18, it means the formula is not correct. If you get the same answer, it means the formula is correct. Then you would have banked all the marks under this section or in this question. And let's move on really to the next question. We can label this question C. So now we're given the quadratic sequence, and now in this sequence here, really we have x and y as unknowns, and we asked the first question to determine what x and y is, and the last question to determine what nth term is. And as you know, the nth term, tn an squared plus bn plus c. So we need to find what x and y is. And as always, you're not supposed to panic when you see this. You just need to construct a tree line of differences, and it will rescue you and it'll save you a lot of headache. So we're going to go ahead and try to find out the values of x and y are. Saying t2 minus t1, t3 minus t2, t4 minus t3, t5 minus t4. It will be x minus minus y, 1. So it will be x minus minus 1, which is nothing more than x plus 1. And then we're going to say 3 minus x, which is 3 minus x. And we're going to say 8 minus 3, which is 5. Then we're going to say y minus 8, which is y minus 8. So we're going to continue and get second difference. That's 3 minus x. And how do you calculate the second difference? I'm going to say 3 minus x minus x plus 1. Then we're going to say 5 minus 3 minus x. Then we're going to say y minus 8 minus 5. And really this looks a little bit messy. So just really try, really visually look at how you can simplify this. So it will be minus x, multiply n by negative, it will be minus x and minus 1. So we can simplify this by saying this is nothing more than saying common factors negative x and negative x will give you negative 2x, and then 3 minus 1, it's nothing more than just positive 2. And then we move on to the next difference, where it's 5 minus 3 multiplying by negative plus x, not 8, plus x. So 5 minus 3 is 2 plus x. So we can just simply, really instead of writing that, we can just go say this is 2 plus x. Then we continue our mission of clearing really all this untidiness. And we will get that to be y minus negative 8. Negative 8 minus 5, it's nothing more than 8 plus 5, which will give you 13, but negative 13. And this looks more pleasant. So what we're going to do here is very, very important, because remember the property of a quadratic sequence is that we have your first term, a row of first terms, right? And then you have your row of second terms. But really the second differences really are equal, meaning that these terms really are supposed to be equal. But remember, we're solving for x and we're solving for y. So what we do, we identify a pair that we can equate that have the same value. So you can see that this pair here, that really expression and that have x, but this has y. So what we do, we take the two that have the same really unknown value and equate them and solve for the unknown value. So we're going to have, what we're going to have is, we're going to have negative 2x plus 2 is equals to 2 plus x. Then we go ahead and solve for x. Take the x to the left hand side, it will be negative 2x minus x. We take the 2 to the right hand side, it will be 2 minus 2. Then we're going to have negative 3x is equals to 2 minus 2 is 0. Divide both sides by negative 3. We're going to get that x is equals to 0. So since we found that x is equals to 0, what we need to do is nothing more than really substitute the x where there's x and equate it to the unknown. You can choose either that expression, the first expression, or the second, or really to equate it to the third. So we can just take 2 plus x and equate it to y minus 3. So we're going to say 2 plus x is equals to y minus 13. Where there's x, we substitute 0. So we'll have, really take the 13 to the other side, 2 plus 13 is to y, so therefore our y value is equals to 15. So we would have calculated what our x value is and what our y value is. And we can move on to the next question because we answered the first question. The next question says, hence or otherwise calculate the nth term or the general term. So what we can do, just to erase this part and really substitute our values of x and our value of y. Then we can go ahead and calculate. We know that our x value that we calculated is 0, and we calculated that our y value is 15. So we continue with our tree line of differences, which will be 0 minus minus 1, 0 minus minus 1. Notice that whenever I have minusing a minus with the minus, I put it in brackets so that there's no, don't make any mistakes. So 0 plus 1 is nothing more than 1. Then it will be 3 minus 0, which is 3. Then it will be 8 minus 3, which is 5. It will be 15. 15 really minus 8, which is nothing more than really 7. So we found our first row of differences. Now we need to find the second row of differences. And we're going to say 3 minus 1 is 2. 5 minus 3 is 2. And 7 minus 5, it's 2. And we're calculating the general term. So we know that 2a is equals to 2. 3a plus b is equals to 1. A plus b plus c equals to negative 1. So we go ahead and find our a value, b value, and our c value, and we're going to determine our general term. So we're going to start 2a is equals to 2, and a will be equals to 1. Then we move on to 3a plus b is equals to 1. 3a plus b is equals to 1. We substitute our a value that we calculated, which is 1. Plus b is equals to 1. Then b will be equals to 1 minus 3. B will be equals to 2. Then we go to a plus b plus c is equals to negative 1. A plus b plus c is equals to negative 1. We know our a value is 1. Our b value is negative 2. Plus c is equals to negative 1. So 1 minus 2 is minus 1. C is equals to minus 1. C is equals to minus 1 plus 1. And c value is equals to 0. And therefore, our general term is Tn is equals to our a value is 1. 1n squared, our b value is minus 2n, and our c value is 0. Therefore, Tn is equals to n squared minus 2n is our general term. And as always, check your general term. You can substitute n of 4 to calculate what your T4 is, and you should get 8. Means where there's n in this equation, you can substitute 4 and see if ever you do get 8. And if you don't get 8, your answer is not correct. And if you do, brilliant, answer will be correct. And really, that will be the end of the lesson. I showed you 3 variations of a quadratic sequence and really pulled them up. And some of them are challenging, but some of them are a bit monotonous. And that will be the lesson.